In this video, I'll present the mathematical models that are associated with potential energy and conservation of energy. So first we have gravitational potential energy, which we'll use U. The U is for potential energy, and then the G means it's gravitational potential energy. That's mass times G. So this is the at the surface of the Earth, the acceleration of gravity. G. This is a positive number. Often when we're doing kinematics, we use an acceleration in the y direction of minus 9.8 meters per second squared. That's minus G. G itself is always a positive number. So this is a mass times 9.8 meters per second squared times y, the height. Then we have elastic potential energy. So this is potential energy of a spring. So elastic or spring potential energy is 1/2 K. K is the spring constant, or sometimes it's called a force constant of a spring. It's always a positive number, and it defines the stiffness of a spring. The larger K is, the more difficult a spring is to stretch or compress. So that's the spring constant, and then x squared. This x is the distance from the equilibrium position. So when the spring is at its natural position, that's x equals 0. As you increase, or if you could decrease, you're moving away from that 0 position, so x gets larger as you move away from equilibrium. X is not the length of the spring. In this condition, x is 0. It's not the length of the spring. X is how far it moves from that natural length, or equilibrium length. To do conservation of energy, we need to figure out a total energy. So the total energy is equal to kinetic energy plus gravitational potential energy plus elastic potential energy plus thermal energy. Then conservation of energy. When there are no external forces that are doing work on the system, then the initial energy of the system is equal to the final energy of the system. Or if there is work that's being done on the system by an external force, then the work done by that external force on the system is equal to the final minus the initial energy of the system. So this is just like before when we were looking at just forces. You have to define what your system is. Any forces acting inside the system, within the system itself, aren't going to do work on the system. These are the ones that are affecting from outside. So an external force. Those are the ones that change the energy of the entire system.